This
Yeah.
conference will now be recorded.
So mostly, I explained this. So this is the comparison, the evolution of Docker. First, we were using bare metal. Whenever you need some application, let us discuss this. I will do it very fast because most of you are aware. Earlier, maybe 15, 20 years back, so this is a one bare metal server, just like our server in our data center. There, once we procure the server, first we were doing the OS installation and then power, network, and then we were installing our application server. Like if you take any Java application server like JBoss or WebSphere, WebLogic, all these things we were installing, and then we were installing the application like WAR file or JAR file or EAR file. Then we were accessing the application. So this is the whole process, actually very big process. This is a bare metal. Everything we need to manage here. We need to install the OS, we need to connect the network, we need to install the application server, and we need to install application libraries, supporting libraries like Java, runtime, all these things we were doing manually. This process was taking more than a month, starting from the server procure. So this is a very difficult process. We came up with virtualization. Here virtualization, you take one very large server which has more number of CPUs and more storage and more RAM. Then we will divide that we will divide that hardware into multiple host OS using hypervisor. Suppose you take one bare metal, you have for example 16 CPU and then for 64 GB RAM, you will have one host OS, and on top of it you will install hypervisor like Oracle virtual, where and on top of it you have multiple guest OS. So here you will have Windows, here you will have Ubuntu, here we will have CentOS, and here you will have Red Hat Enterprise Linux, like that multiple OS. And you will allocate a memory like 4 GB here, and then 2 CPU, you will allocate here 8 GB to CPU, like that you will divide, and then you can install the applications. This was very fast because you no need to procure the servers again and again. This was also, now the traffic is like millions of requests per minute. If you take any Amazon kind of applications or Flipkart, you will get 10 lakhs requests, and then at the time of big billion day, you will expect crores of requests also. Suddenly, if your application is facing more traffic, for you to scale the application with another server, it will take here 10 to 15 minutes or 5 to 10 minutes also. Within that time, you will lose the customers. At the time of big billion day, if Amazon and Flipkart both opens a big billion day, if your application is responding 5 minutes slower, then obviously customers will go to another application. So that's why this is virtualization is also was not also working as per the customer satisfaction. So now we started with the containerization. Here containerization, you will have one CPU and memory and host OS. Your containers can start within 10 to 15 seconds. Your application can scale to handle millions of requests, and then it will also scale down to reduce your number of servers if your traffic is going down. So if you compare this with some features like reliability, because your application is starting very soon, you are with Docker containers, so you can easily trust this application, and then whatever you deployed in development, it will go to the production also. Usually if this is not the case, then what you do, you have to manage the dev servers, you have to manage the staging servers, you have to manage the production servers. You don't know what is the configuration in dev. Mostly the configuration is not 100% same. But in case of Docker, the configuration is same across all environments, whether You deploy your application in development, it is the same as in production. So you will not face the situation like the application is working in development, not working in production. So Docker has that feature, simply build once and run anywhere. When you build the image, you can move that image to all environments with the same configuration. We can see how that is achieved. And the memory is very less. In this case of guest OS, this may be like 4 GB, 8 GB also. But here the operating system memory is like, if you take Alpine, that is 5.6 MB, equal to an MP3 song. But here it is maybe 4 GB, 2 GB also. When obviously when the memory is very high, the booting time is very, the booting time also takes more time. But here the memory is very less. Maximum, if in production environment, we will run the applications with 200 MB only. Then the booting time is very fast. So that is the memory. That's why the boot time is very less. Your application can easily scalable to any number of containers. And then resources optimization. Here, in VMware, you will allocate some memory like 2 GB and then 2 GB RAM and then some CPU and storage disk. This guest OS will completely block it, whether you use it or you don't use it. But here it will not block. It will directly take the memory and CPU from the host. If your application is only required of 1 GB RAM and then 2 GB hard disk, then that amount only is consumed from your base server. Okay, so that is why the memory is also, the resources is also well optimized here. And best for microservices. Microservices means, like earlier we were deploying the application in like one single monolithic application. Now everything is microservices. If you take Amazon.com, everything is a microservice here. This is orders microservice. This is cart microservice. This is product catalog microservice. When this is not working, you can still expect these orders. Sometimes your cart functionality may not work, but still you can able to search your products. So that is the microservices. So this containerization is very good for microservices. We can do one real-time project like this of e-commerce application in our session. We have the cart microservice, we have the order, product catalog, everything. We can see how can we deploy as Docker containers. Okay, so that is the advantages of Docker. And what is Docker? You will face this question. Docker is, you will have one base OS, like you can have Ubuntu, CentOS, Alma Linux, Alpine, and on top of it you can deploy Tomcat or Nginx or JBoss and the libraries required for your application. Then you install your application and create an image. So that is the Docker image. You ship this image to any environment, that will work same because it is isolated from the base OS. This container has its own OS. Like here, if you say this can be Ubuntu, and on top of it, you will install Tomcat or Nginx, copy your application, then create image. So this is how you create your Docker image, and it is immutable. No one can change it. So you ship this image to all environments, your application will simply work. So that is the power of Docker actually. These are all the advantages. And in Docker terminology, we have base OS and then image. Image is same as when you are installing a OS in your laptop also, that is called as image. And the container, when we run the Docker image, it creates a container registry. Docker Hub, it is like which holds the all base OS and volumes. You can attach your volumes to it. Docker Hub, public repository of Docker images. So what we used to do is, we will get the base OS from here, and then we will install the libraries and then few softwares on top of it. For example, if you take Ubuntu, we will get this Ubuntu image. On top of it, we will install Nginx and copy your application and create the image. This is the Docker terminology. And Kubernetes. This is the main of our training, not Docker. Docker, we will cover it like 20%. We will see how to install Docker, how to what are the Docker commands, what is Docker file, how to create our custom image, and what are the best practices to write a Docker file, how to reduce the memory of Docker image. All these things we will discuss in this security part as well. And Kubernetes is like orchestration of Docker containers. For example, your application has 10 Docker containers. Or let us think servers first. Suppose your application is very old and you have thousands of servers. If you want a change, how can you do this change in all the servers? Usually we will have the configuration management tool, right? Like Ansible and some configuration management tool. So usually this connects, you do the changes in this tool and you push the changes to all the servers. That is the practical. Otherwise you need to log into each server and do the change and log into this. Similarly, thousands of servers if you have, you cannot do the changes at a time. But if you do it in configuration management tool, this will push all the configurations to this. So this is called as orchestrator. Simply like here, somebody is sitting in front of all the persons who is playing music and he will give the instructions. He don't play the music, but he will give the instructions. Like our manager, they don't do the development, they don't do the low level work. They are the orchestrators for us. They will guide us, they will direct us how to work, what to work. So similarly, Kubernetes is that kind of tool, orchestration tool. So we will face this question, what is the difference between Docker and Kubernetes? Docker is the containerization tool, but Kubernetes is the containerization orchestration tool. Kubernetes itself is not do anything except it will pass the instructions to the Docker containers, what to run, how to run, uh, how many replicas to run. That is the part of Kubernetes. So the features of Kubernetes are, you can only use Docker. You no need to use Kubernetes. But if your application has lots and lots of containers, then you should use Kubernetes. Otherwise, you cannot go to the each container and do the changes. This Kubernetes advantages are self-healing. For example, this is Kubernetes. For some reason, this container one is crashed. Then immediately it will spin up container two. I mean container one, another replica. So your Kubernetes will always check whether the container one is running or not. For some reason, if this is crashed or restarted or something goes wrong, this Kubernetes will detect it and then soon it will start another version. I mean the same in another worker node or somewhere. The responsibility of Kubernetes is to make the applications running all the time. That is called as self-healing. If something goes wrong, it will immediately create another copy. And config maps and secrets, you can have some configuration maps like environment variables and then credentials. You can store it in Kubernetes. Your containers can refer them dynamically instead of storing or hard coding in this area. And auto scaling, Docker will not give you auto scaling. If you want auto scaling, you must implement Kubernetes. For example, now if your application face the huge traffic of 10,000 requests suddenly, Kubernetes will detect and then it will create the copies like this. It will create multiple copies. copies automatically to handle the huge traffic suddenly. So that is auto scaling. Automated rollout and rollback. When you deploy the container using Kubernetes, if something goes wrong at the deployment time, it can automatically roll back to the previous version. For example, today you have a big production release, and suddenly your app is not responding well with the new changes. Without Kubernetes, you need to do a lot of things. You need to stop the server, you need to get the previous version, you need to make it running again. But with Kubernetes can automatically detect whether the new version of your application is running or not. If it is not running, it can immediately roll back to the previous version so that your application business will not break. And then load balancing. If you have multiple containers for one application, it can do the load balancing automatically between all your replicas, and it maintains the state. Whatever you give to the Kubernetes, I want this application, 4 replicas, this configuration, then Kubernetes will always uh, check that configuration. If something goes wrong, it can bring back to the previous state. These are all the Kubernetes advantages. If someone asks you why you need Kubernetes on top of Docker, these are the features not covered by Docker. So Kubernetes became popular orchestration tool now. If you take the architecture in any platform, there will have master node and then worker nodes. Your master node is the Kubernetes actually. It will have API server, scheduler, control manager, and etcd is the storage. Whenever you push some application to the Kubernetes, API server will get that configuration and it will send the configuration to the scheduler. Then scheduler will schedule an application to one of your worker node. It will check which worker node is free. Then it will schedule your application in that worker node as pods. Okay. And then this control manager will always check the applications are working and responding properly. etcd is for the storage purpose for all your configurations. So this is the Kubernetes architecture. We cannot discuss this more and more now because we will not understand. But all these components we can discuss in our training session. And Kubernetes is like we can maintain the Kubernetes in on-premise servers. If it is a banking application, banks will mostly maintain the Kubernetes in on-premise. If it is cloud, then we can go to AWS and then Google Cloud and Azure. But anywhere Kubernetes concept is same. If it is on-premise, you need to manage the master node like this one. You need to upgrade, you need to do the authentication, you need to manage the storage, everything. But if it is cloud, AWS will manage everything for us. We just need to know how to create a EKS cluster in AWS. We will discuss both. For simplicity, first we will go with AWS. We will install one EKS cluster and then we practice the Kubernetes resources like this. What is namespace, pod, sets? All these things are very important in our interviews and daily work. How can you create deployment? How can you create service? What is config map? How you refer the secrets? What is ingress? Role-based access control, horizontal pod auto scaling. And these are the Kubernetes. Once you understand all these things, then we can discuss about the Kubernetes uh, internal core components. Like we will face this question: what is etcd, what is the Kubernetes architecture, when I push the application to Kubernetes, what happens? All these things we will face in the interview. And some other topics is like we will take one open source project, e-commerce. We will create the Docker containers and then we will deploy it into the Kubernetes platform. And after all these discussions, we have some advanced concepts like Helm charts and operators. This we can discuss. If I explain, maybe we cannot understand. And then we will use Jenkins CI/CD to deploy our applications to the Kubernetes platform. And we can discuss one sample CKA exam. And the other topics are ELK, and then here ELK means EFK. we will get these logs from the containers using FluentBit, and then we will push it to the Elasticsearch. We can see the logs using Kibana, and we will monitor the cluster using Prometheus and Grafana. We can see all our Kubernetes master component, worker nodes, and the applications inside the worker nodes are all running fine with Prometheus and Grafana. So these are the topics we cover. To the low level, first we do the Docker installation, and then we will discuss Docker commands and Docker file instructions and running application through Docker container, volumes and port expose, best practices, multi-stage builds, and then security in Docker container. So these are the basics we must know before going to the Kubernetes. Once we understand all these things, then as explained here, we can discuss all these topics with EKS, and finally we can deploy one cluster in our on-premise environment. And these are the topics we will discuss. So this takes around 30 to 40 hours, I can say 35. And at the end of this training, you can always answer the questions. I can share some Docker and Kubernetes interview recordings also. Any doubts?
Yes, yeah. The thing is this course is mapped with the syllabus of CK exam. Is it same with as per the CK exam? Because my aim is to clear the CK exam. That is the reason I'm just asking this question.
Yes. Yeah, actually, this is more than CK. In CK, you will face the questions only till here, maximum here. We will discuss one sample CK exam also.
Okay, nice. Thanks.
I can say this is more than CK.
Great. Thank you.
Yeah. So I explained in a high level because most of you are all working in DevOps. When we start the sessions, we can discuss very low level, all these topics, whatever
Shiva,
I
this is
explained now.
Hari.
Yeah, hi.
Yeah, so like in the Dockers also we are going to cover everything, or as you said, only 20% we are going to cover. I did not get over there, so might be a miss. So that's
Okay.
why I'm asking.
I mean, in Docker and Kubernetes, Docker is 20%. This is the whole Docker actually. This is the whole Docker
Okay.
syllabus anywhere. I mean,
Okay.
Docker is 20% of this Docker with Kubernetes.
Okay.
Docker is the base for Kubernetes, so we discuss Docker more. Actually, this is 100% syllabus of Docker.
So I have another question. Like, see, you are saying like Docker we will be using with the Kubernetes.
Yeah.
That is one thing. And another thing, without the Kubernetes also we can use the Docker in any of the environment.
Yeah, without Kubernetes also you can run your application through Docker container, but it will not scale. You will not get all these features.
Oh, okay.
Like these features,
So
right? So if something goes
yeah.
wrong your container, you have to go and manually check it, and then you need to restart it manually. And if the traffic is getting more and more, you need to start multiple containers manually. So all these things you
Okay.
need to manage. So that's why we have Kubernetes, like a manager of containers, manager of Docker.
Okay. So integration of both only we can explore the all the features and everything.
Yeah, integration of both,
Okay.
you can achieve the best results in real
Okay.
time.
Hi, Siva.
I have,
I have posted few questions in the private chat.
Okay.
Some of the questions were answered already while you were explaining the things. Can you go through questions on CK?
Okay. Docker will be out of support, then how will this course be useful? What about Podman? Correct me if I'm wrong. Docker is not out of support. Actually, earlier Kubernetes platform default container runtime is it's about container runtime. Docker is not a new tool actually. Docker contains mainly container runtime. Now it uses container D. Container.d is the runtime of Docker. Whether you use it Podman, whether you use it Runc, there are multiple container platforms, but Docker is more popular because it has its imaging support and runtime. It's a mix actually. Kubernetes choose the runtime as default runtime as something else. Okay, I can show you that latest news. Four days ago. Earlier, we were using directly Docker in all our worker nodes. Now, Kubernetes will go to the another level, container runtime. So this is CRI. CRI interface, I want to say actually. CRI is a container runtime interface, and container D, Runc. There are multiple things implemented this one. Okay, so like Linux is the base, and we have multiple flavors, right? Like CentOS and then RHEL. This is the base actually. CRI is the base for everything. Docker is also one of the implementation of CRI. So there is no there is no stop support on Docker actually. It is not the case. It is only the container runtime. Still Docker is supported. Kubernetes, you can just play with it. And then we can see one more like Podman also. Since this is the latest news, we can do one more like Docker. And yeah, this is there. We have an open source microservices project that contains 12 microservices. We will implement that in our training session, and we will use Git. I will post all our applications in our GitLab repository. You can have access for it. And this is with Jenkins CI/CD pipeline. Monitoring tools, Prometheus and Grafana we will cover. Recordings will be provided on daily basis within 1 hour. Installation, configuration, all I will provide through the README files in our GitLab. Without Docker, we can't use Kubernetes. Yeah, actually Docker is a containerization implementation actually. One of the implementation of container. We will have another tools like Podman, Runc, LXC, lot of things, but Docker is more popular. So we are discussing Docker. Basically, we can say Kubernetes is container orchestration. Docker is one of the container approaches. Any other doubts?
For example, the container is very minimal kind of operating system, right? So it will not having the enough commands for an administrator. So I think you need to install extra commands which we need to troubleshoot the application or something, right? So will you cover that part, at least kind of introduction?
Yeah, actually how we troubleshoot Docker applications is you will not for example, if you want a telnet tool or ping tool in your Docker container, we don't install them in it. We will provision another container. From there, we will try to access that application. Usually for security in your applications, we will have base OS and application runtime and libraries, and then your actual application. That's all. You don't install your monitoring or your troubleshooting in this actually. If you do this, then hackers will take that advantage. You create another container in the same namespace, and here you install troubleshoot like telnet, ping, let's add something, whatever. You install here, and from here you troubleshoot this application. Okay, but Docker is immutable. If this works in dev, the same image will works in production also. If it is not working, you don't need to do anything here. You need to take care of another configurations like Kubernetes configuration. You don't need to touch the Docker container once it works. That is the Docker responsibility and most popular feature. Build once and run anywhere. If your application is not working as expected in production, but it worked in dev, then it is not your container problem. It is the configuration problem.
Siva,
Okay.
I have one doubt regarding the duration. Is daily or it's a weekend class?
Yeah,
What way it is?
daily morning
That's
6:30 to 7:30 a.m.
that's nice timing, and it's a good that you have daily, because we can finish it off in a quick shot of 1 month, right? It will run
Yeah,
approximately a month.
yeah,
That's
I
nice.
choose
Yeah.
daily because morning time I feel fresh. You will
Yeah.
also feel fresh to receive, so that
Perfect
we
time.
will
Yeah.
not have work pressures on us.
Yes. Correct. That's a nice idea. Yeah.
Yeah,
So Shiva, you will be covering AWS cloud, right? So
yeah.
if we get into one cloud, then we will be familiar with AWS, sorry, Azure cloud and OpenShift also, right?
Yeah, 95% Kubernetes concept is same. Like Kubernetes is the base for everything, 95% same. And Amazon EKS is one of the implementation, AKS is one of the implementation, and GKE is another implementation, OpenShift is another implementation. Maximum 2-3% only will be changed. That too, it is a graphical user interface, not the functionality. Functionality is same everywhere. So if you know
Yeah.
the actual Kubernetes, then you can handle anything.
Okay, got it.
Just
Thanks, Shiva.
yeah, just like your Linux. If you know Linux, you can handle any OS. Like yeah.
Shiva, having one question.
Okay.
So currently we are using the Docker container for one of the third-party tools. So
Okay.
there is what happening is we have implemented the EC2 scheduling. So at the
Okay.
time it is getting stopping. When it gets stop and started, so Docker container is not running automatically. So is
Okay.
there any chance to run it as a service file?
You can have one systemctl shell script there. At the time of starting your EC2 server, you need to give the commands to run Docker containers, like Docker run. All the commands you need to list down, and you need to start the script at the time of your Linux server boot up. You can create systemctl service for it.
Okay. And one more thing. So currently we are using the Amazon EC2s. Okay, and in future we are planning for the GCP. If we implement
Okay.
the Kubernetes on Amazon EC2 and we can migrate to GCP also.
Yeah, images are same everywhere. Your Docker images are same. They work 100% as it is. Either you move them into the EKS or GKE or AKS anywhere. The images, Docker images are always same. It works 200% same in all the
Oh,
platforms.
okay, okay.
Shiva, Gopi here.
Yeah, hi Gopi.
Yeah. So we have project also, right? CI/CD implementation from Git
Yeah,
to containers, container
yes.
orchestration.
Yeah. What we do is we will write Docker files. For example,
Okay.
before that we will have Java application, Java microservices,
Okay.
and we will build this application, and we build the image, we push it to the Nexus, and then we will deploy into Kubernetes. So all these are
Uh,
like CIC, with CI/CD only.
Okay, and we have database also backend, right?
Yeah, database also in containers.
Okay, so if we want to push the database changes, for example, if I want to add any table or those kind of things, so those things also can we do using CI/CD?
Yeah, database also you can do the CI/CD. So there
Okay.
are some tools for database. Uh, what is that is you will have your SQL files, right? Your database
Yes, yes,
tables means just your SQL file. You take the
yes, yes.
change in this SQL file and you push the change to the database. Then you will have
Okay,
your new columns and new tables created. Then after that you deploy your application. That is the approach actually.
okay. So currently I'm using PHP application, so that is an EC2 only. So we are
Okay.
planning to migrate to Docker and Kubernetes. So that's why I'm
Yeah.
choosing this course. So if we
Yeah.
have
Yeah.
that
You can.
content also, then definitely it will be more useful to me.
Yeah. So either it is Java or Python, PHP, the process is same actually.
Okay, okay,
Only the base image will be changed.
okay. So here not only Docker Kubernetes, we have Jenkins and all the deployment strategies also, right?
Yeah, correct.
Okay, fine. So it will more useful to me.
Nice. Actually, we are also migrating few of our monolithic applications to the Docker and EKS.
Okay,
Same like you. We have some legacy PHP applications.
okay.
Yeah, we are also migrating.
So I have a PHP and Node.js application that is a gaming application. So it's a school level kindergarten application.
Okay.
So we need to migrate it into Kubernetes, Docker and Kubernetes. So currently
Yeah,
it's in
yeah.
POC.
Yeah,
So I think
definitely
it's
we
in
can.
two
You
to
can
three
do
months. I
this.
need to work on this one.
Yeah, you can do that.
Okay, thank you.
Bro, I have one doubt, sir.
Yes, Ravi.
Hello? Bro,
Yeah.
we are using our base image as a Docker file, right? So we can also create a base image, right? I mean, instead of using, for as per need basis.
Yeah, you can create your base image for your organization. You take one
Okay.
plain Ubuntu, and on top of it, you can harden that image. You can install your organization default tools, and you make it as a base image for your organization.
Okay, bro.
Is there any chance to practice on your Red Hat images in our training?
Yeah, everything we take it from the scratch. We will create the EKS, we cluster from the scratch. We will deploy the application from the scratch. We record it. You just watch again and then do it in your own AWS account. This is completely practical. You can just do it once again in your own environment.
Sorry, Shiva, maybe I didn't ask you the question properly. My point is, Red Hat images are, paid versions, right?
Paid versions.
Yeah, Red Hat
If
images.
yeah,
Red Hat
so
will,
Red Hat is a paid version, but CentOS is not the paid version. Same as Red Hat.
okay, we will
It's a
practice on Cinder. Okay, then
yeah, it's a
fine.
community. Yeah. Any other questions? So tomorrow at 6:30, maybe it may be difficult, but there is no other way. Any other questions?
And the total duration will be from it's like some around 30 days.
Yeah, it's will be like 40 days.
Okay.
It's based on
And
our flexibility, 5-6 hours.
okay. And so this is only on weekdays or it's on weekend also?
Monday to Saturday. Few Saturdays we take, few times we
Okay.
can leave. Monday to
Fine. Fine.
Friday is mandatory. Yeah.
Sure. Sure.
If you miss some of any, maybe 1 day or 2 days, you will get the recordings. You can go through and then you can ask the questions.
And so what kind of lab environment you suggest? Whether we can create one lab environment in Amazon or Google?
Yeah, Amazon. We use Amazon.
Okay.
So you create,
EKS.
all of you create
Yes.
one AWS account.
Yeah, I have already. So this is the base for this course, right? So
Yeah, it's
yeah,
must.
so all our examples will be based on the EKS.
Yeah, EKS.
Okay, fine.
I mean, you can run it in Google Cloud also. It will work.
Okay,
But for us, we need to select one cloud environment, right? So that's why I selected AWS. You can use
fine.
Google also if you are familiar. Yeah.
Okay. And another question is, in this course, you have two instructors, or you are the only instructor?
No, I'm the only one.
Okay, fine. Because I came to know about this course from a group, WhatsApp group, and it was run
Okay.
by a person called Raghu. So that's the reason I just asked. Raghu also will be part of your team, or your separate team?
Raghu teach DevOps. I know Raghu
Okay.
from long back. We were
Okay.
colleagues.
Nice. Okay.
So Shiva, you will be covering Kubernetes setup in on-premise infrastructure also, as well, right?
Yeah, on-premise also. First we go with EKS because if we cover it, the installation in on-premise, it is little complex. You will not get that. I mean, you feel it is complex. So first we will
Yes.
understand all these components of Kubernetes. Like if I ask you to learn Java, if I tell you Java history, Java features, you don't understand. But if I run you through few programs like Hello World, Fibonacci series, and later if I explain about what is the Java features, then you will understand very well. So that's why first I will go with AWS EKS, and you will understand all Kubernetes concepts. Then we can discuss about on-premise installation. You will get it nicely. You will understand nicely.
Sure.
If any other questions?
After the course,
So let's,
if in shall I talk? Somebody?
please.
Yeah. Yeah, it's me, Sindhil. So, after the course, my plan is to write the CK exam. So, after the exam, and I need to apply for jobs. So, will there be any support from your side to get the job, something?
Yeah, actually now the market is very good
Or
for
else,
DevOps, and I can provide you the resumes, and I can provide you the interview questions and interviews already we have recorded. So then with
okay.
them you will easily get lot of calls if you just put your profile in Naukri. So that kind of support we can do, like
Okay,
providing you
nice.
the best resume and then preparing you for the interview.
Okay, nice.
I can show you like my resume, but this is heavy. You no need to, or I can show you some other resume, not my student. No, this is not DevOps.
Each day is 1 hour or 2 hour? What's the plan?
1 hour, 1 hour, 1 hour.
Okay.
So 6:30 to
This is
7:30, right?
yeah, 6:30 to 7:30. So this is the sample resume. Either you change your company from one in DevOps from one company to another company, or you are now starting as DevOps. You need to highlight what are the tools you learn like this. If you know Docker and Kubernetes, just you mention here Docker and Kubernetes also. This is the our best resume. Usually we get more calls to this. Okay, so here like this you mention experience in Kubernetes to deploy, scale, load balance, and manage Docker containers, Docker this part, and scaling and management. So these points we will learn how to explain all these things. Okay. Any other questions? You create your AWS accounts today. If you don't have, then tomorrow straight we can install Docker and then we can practice it. So if no questions, we can end this session today. Any last questions?
Shiva, last and final question.
Yeah.
Are we going to see any Fargate or only EK?
Fargate is ECS. ECS is
Yes.
like ECS is not a Kubernetes implementation. It is a Docker Swarm implementation.
Oh,
Fargate is very easy, just like a Docker, not like a
okay.
Kubernetes. We can discuss. Maximum it will take 15 to 20 minutes. We can discuss
Okay.
it.
Okay.
Yeah. Okay. So if no questions, we can meet tomorrow 6:30 a.m. Thank you. Have a nice Sunday. See you.
Thank you, Shiva. Have a good day. Bye.
Bye bye.